Hey, welcome back to the lecture. Let's continue our debugging session, and in this lecture let's explore about the call stack feature of the IDE, and this feature is supported by all the major IDEs like Keel, Eclipse, Code Composer Studio, IAR, etc. So you can also experiment on your own IDE if you are not using Keel IDE. Great. So now let me give you an use case scenario before I introduce you call stack feature. Okay, so now what I do here is, so I will just create one function. So now let me just create one function, void function1. Okay, so just a dummy function. And here I call function2. All right, so I just call function2 under function1. So I will implement that function2 here. I'll just call this function2, and in function2 I call function3. Again, I have to define function3, right? Define that here, function3. So in this function, I just create one function pointer. So void, let's say jump addr void, and I initialize this function pointer to some address. So let's say 0000 and 0000. Great. So now what I do is I try to jump to that address, okay, by dereferencing the function pointer. So if you are new to function pointer, or if you're not understanding this code, so let me explain. In the first line, this is very simple code where jump underscore addr is a function pointer. So it's not a normal pointer, it's a function pointer. Suppose, let's say if I write int star p, here p is a pointer variable which is capable of holding a pointer to some other variable or to some other data. So similarly, jump addr is a pointer, but it doesn't hold address to a normal data, but it holds the address of another function. And so here this declaration says that jump addr is a function pointer. That means it is capable of holding address of a function which takes no arguments. That function doesn't take any argument. That's why I have mentioned it as void, and that function doesn't return anything. That's it. It's a very simple way of expressing all these details in this fashion. And I have initialized this jump addr, that is jump address, to some invalid address 0000. So that's not a valid address. And then I'm jumping to this address by just dereferencing that one. So I can even do like this. So I can just do like this and delay. So here what I'm doing, so here I have to change the name. Let's say jump addr1. So here I am assigning the address of delay function to this function pointer. So if I compile this, you can see that both code will compile successfully. So there is no problem with that. So now if I do jump addr1, now if I dereference this, so what happens? Control comes to delay, isn't it? Okay, so it's like that. So I'll just remove this now. So now, so what exactly I'm doing here is, when the control comes here, the program counter will be loaded with this address, and the processor will try to fetch instruction from this memory address. And this is, since it is an invalid address, there is no valid instructions present. So that's why the hard fault exception of the processor will be triggered, and we will be trapped in the hard fault handler that we'll see now. Great. So this is experiment we are doing, and I'm calling function1 from while1. So when the control comes to main, it goes to function 1, then it goes to function 1 here, then it goes to function 2, and it goes to function 3. And in the function 3, we do this illegal action so that we trap our processor in the hard fault handler. So let's see how this works. So let's compile this code and let me flash it. So it flashed successfully, and now run the code and just reset your board, and you can see that your code is not working. That means these codes are not working. Why? Your LEDs are not toggling, isn't it? So that's because something bad is happening in the code. Now, how do you debug this? So these kind of things will happen in your project development. When you have multiple source files in a project, then if something is not working, then how do you debug this scenario? In this case, our expectation is our LEDs should glow, isn't it? But it's not working. So how do you debug? So how do you pinpoint the problem? The problem is actually hiding here, isn't it? So one way of tackling this issue or finding out the problem is by using call stack feature of the IDE. So now what I do is I put the board into debug mode first. So now the board is went to debug mode, and I open my call stack. So call stack is actually opened here. So I will tell you how you can open that once again. So go to view and click on call stack. So now the call stack window has come up here. Okay, so now hit run. So now the code is doing something bad. We know that because it's supposed to execute our LEDs functions, isn't it? So it's not doing that. So what we do is we'll stop it. And when we stop, we see that my code is actually trapped in the hard fault handler. So why that is happened? Because we actually moved the processor to fetch instruction from illegal address. So now, how do you identify which line is causing the issue in your source code? For that, take a look into call stack. The call stack will trace out what and all function it executed before hitting the hard fault handler. So the call stack is giving you a hint that before reaching hard fault handler, it executed function 3. So that's the hint. So now I can easily go to main.c and I can review this code, isn't it? Oh, I'm doing something wrong here. So what I do, I immediately put a breakpoint here at the beginning of the function. Then I reset my processor. And now I hit run. The breakpoint is coming to function 3. So everything is fine. The call stack is saying you started from main, you went to function 1, you went to function 2, and you went to function 3. Everything is working great. And this is the line which is causing problems. And I remove this, and when I hit run again and stop, you can see that the code is trapping in the hard fault handler, and the call stack is saying the last function which was executed is function 3. So I know that till here everything worked fine. After this line, I'm getting hard fault handler problem. So that means this line is causing issue. So that means we are jumping into illegal address. So that's how you can use the call stack to, trace out where exactly is the problem. So this call stack feature is heavily used and in debugging, and it is available in almost all IDEs. And if you are using Eclipse IDE, I suggest you to try it, okay, on your Eclipse setup, which we discussed in the last section. Hey,